Hello, people. We are live and on time today. Great. I hope you are all well. I am, and I'm excited then because since last Friday, we know for sure that Tiny Tapeout 2 has worked. I think there were. If you didn't watch the stream, I should watch link the stream from last Friday on Matt's channel. Sound is low? What? Oh, actually, you're right. I don't know why. I will crank it up. Here we go. I don't know why. Why is it so? Let me check. Is this minus 30 dB? Yes, it is. Uh-oh. Wait. Okay. Wait. No, it doesn't change anything. All right. I don't know. It's probably Windows again. Doing Windows magic. 0 dB. Okay. I can't change it. Minus 10 is the highest we go right now. Stupid. All right. So let's I will drop the link to the video. Maybe we will even where is it? Videos. Oh wait, that's the wrong. 0 to ASIC, I think it is. 0 to ASIC YouTube. Here we go. 0 to ASIC course. Okay, here we go. That's the 2-hour stream. Here we go. And now I will greet the people so you can watch along. Hey Matthew, hey Matt and Pat are here, which basically we're also on a stream. And hey Tech, hey Johnny, hey Mr. S, Jordy and Ray and Adam. Ray Sigma. All right. Ian is also here. Hello. All right. Looney coins. No. It is the issue is, I mean, it's an ASIC, but we don't utilize like ASIC capabilities yet. I mean, the communication of Tiny Tapeout 2 is limited a little bit because everything is like every project that's on the ASIC is daisy chained. Does it play Doom? It plays different things. Let me first explain. You have an NFT. Oh yeah, Johnny, this is like having one of those ASICs. You might be interested, especially the secret file project on there. So let me explain what Tiny Tapeout is first for the people who are lurking and probably don't know how to make ASICs. So and it unfortunately is a little bit slower than ordering PCBs from JAC, Isla, or PCBWay. But it's only it took us only like 10 months from deployment to receiving the actual ASICs. Here is the screen capture. Wait, here, desktop, face, here. Nope. Screen capture, here we go. Okay, let me explain Tiny Tapeout. So we have, yeah, we did a live stream on that. Okay, so there was like, it's a ton of like companies around that are involved. What I know from like Google wanted to like support open source ASIC development, but now they stopped also. Still, Matt Van is running the course where he offers you to learn how to design an ASIC, or at least a design that can be embedded on an ASIC chip, like in hardware, in silicon, not software, silicon, hardwired. So it's quite difficult to make an ASIC. Let's say this is like your QFN. Yeah, this is your QFN package with some pins here everywhere. And then you have some, internally you have like the silicon die, let's say. And then you need like circuits and manage the I/O and stuff like that. For that, there is Caravelle. This is from my understanding. Please correct me, Matt, if you're here, or Pat, if you're still listening, correct me if I'm wrong. So this is Caravelle. I think it's written like car. Whoops, Caravelle, which is basically a RISC-V. So it has like stuff in there to control the I/Os and so on. It even has a USB interface, I guess. I don't know, I'm not sure. It's a flash and so on. So basically this is RISC-V. RISC-V, Caravelle. And that's basically the frame. Like you are the artist, and this is your frame to work on, like your scaffold or your what? Is there a fuss? Okay. Anyways, what Matt set up is like, yeah. No, it's okay. It's manufacturer programmable gate array. Yeah, not really, because you can do even analog stuff on there. So the newest, this is what I took part on Tiny Tapeout 2, which is already a year ago, and it's more advanced now. So what Matt set up like is a course where the participants can get like a real estate on those chips. Back then it was only like everyone got the same size of the project, and there's like a bunch of those projects and all are open source. Everything of this chip, like the manufacturing process, everything is open source, like how the gates look like and so on. So that was like let's say an attempt to remove all IP from ASIC development. Okay, so Pat says Caravelle has a CPU there, so logic analyzer and stuff to manage I/O interfaces with your project, blah. Okay, so this is like the RISC-V with the I/O stuff and so on. So you can basically, this is your toolbox, which is always attached on the same die, and you can control like the I/Os from it and so on. So how Tiny Tapeout 1 worked is there is a bus, a serial bus that basically shifts an 8-bit register in and out, like to the chain of all those projects. So we have many projects, I efficiently drawn here. I think there was a space like because I think initially it was like a big account, and then since there were not like enough participants to fill the whole space, I think the size increased, and then there were fewer projects. And what's like the essence of that is that you have like, let's say 8-bit or I don't know how many lines as a selector. So you can enable, it's like a chip select, but like you put there the number on the lines here, the 8-bit. Select the active project. So let's say my project would be let's this one here. So if you select that, it will become active. And so let's say beep, this is what we select. And then we have then we have 8 inputs. And 8 outputs. So unfortunately on Tiny Tapeout 2, yeah, there is no separate clock, so you have always like to use one pin as clock, and then you have 7 bits for parallel data or serial data or whatever you want. And there is like your output can be 8-bit because the clock you have you provide the clock here. So this is like 8-bit. Oh, okay, 9 bits. Here, let's correct it. Pat says there is 9-bit select. All right, so and yeah, unfortunately with Tiny Tapeout 2, what was improved is it was like sequential. So if you put in data on that, it will be like clocked through all those designs until it arrives at yours. It will be processed, and the output will be also like shifted through all the designs or the remaining designs or whatever. So what that means that the actual clock, which might be like 50 megahertz here, what did we test? We can see, okay, this is like the RISC-V or whatever. The chip can be clocked like with 50, or we had, I think we tested 10 successfully. That's like this is like the ballpark. We tested 20, okay. So we tested 20, let's correct that. 50 wasn't successful, I think. We had like a test, or there was some awkward things going on. However, if you divide it, like if you have to shift the data through all the designs, at the end you get like in the kilohertz range. Full duty cycle. Okay, so what is our clock that we can use here? So what is the actual clock of our ASIC design input output? Pat, do you still know? That's like a kilohertz range. And divided by 4,000. All right, then we have like 2 kilo. Oh, okay, so that's not a question mark, that's a 2. Yeah. All right. This changed since Tiny Tapeout 2. This changed. I think like they're running now in full shenanigans. Yeah, I'm explaining how the ASIC design or like Tiny Tapeout works. So the result is now we have 2 kilohertz, more or less. I think theoretically we had like talked about 8 kilohertz. And now with the newer tiny tape outs, that's more than like the full 20 megahertz I think you get, or maybe divided by 2. So many people put the data sheet as like 200 pages or something, because everyone had like to put in the description how to activate or what data to put in there and what is the result. So the space is quite limited. If you're familiar with FPGA programming like these here, you have like limited count of gates, and the same is with the ASIC, because you have like limited real estate, or it gets more and more complicated because you have to amplify signals, and if like the lines are too long, then the clock changes or whatever. The integrity is like always, but that's always handled by what's the USIS? No, some planner does that. It takes like on GitHub Actions, my most complex designs with 60% of utilization took, I think, an hour or two to be like calculated and deployed and planned out at the end. So it was like to get a few more gates in, it took ages to like redeploy and test again. However, open lane, open road, always confused the two. I don't know any of the names. Yes. Yeah, and the cool thing is, I think we have like 3 FPGAs on there. Like on this little space, people put like little, with a few gates that you can program serially, and then you have like or tone generators and stuff like that. And I put four designs on there. One is a secret file design, which only receives a clock on the first input pin, and outputs this parallel, parallel 8-bit data. And that would be something like nobody knows what it is. It's a puzzle. I don't know if people already discovered how many LEDs. Oh yeah, that's the good thing. So let me scroll down. Yeah, we can do pink LEDs. I have enough pink LEDs here. So I was thinking about, okay, what can we do in 2 kilohertz range? So what I thought about is, like all those persistence of vision fans, like that have like 8 LEDs, and then this is terrible. Let me switch to text. Okay, we have a fan, let's say as like a blade or whatever, that rotates, and it has like LEDs. Okay, that's only 6. And then it draws like the time or something, let's say, or here it draws like hand low. Okay, so it draws like a text. And what you need for that, let's say if you use like 10 RPMs, which is not fast enough. No, RPM, rotation per second, revelations per second. Okay, so let's say we have like a frame rate of 10, it might be okay, I mean, if it's dark. So we have 2 kilohertz divided by 10 is 200 columns that we can draw in one, like, and how do I, let's use the different, okay. So we have like, 10 revelations per second means we have 200 columns here that we can use as a display. And since our output is 8 bits, one column has 8 LEDs. So we can draw a text with like this 2 kilohertz, we can output a text on a fan or something. So we have an actual project where the tiny tape out like capabilities, TT2 capabilities are good enough to do something actually something useful. I mean, there are probably controllers that are doing that already. So let's take at the data sheet. I hope it's linked in the stream. Links. Okay. Bring up notes. Oh, wait. T2 data sheet. Clock proportional to the rotation. Oh yeah. Runs TT2. What is this? Here we go. Documentation English. Okay, so the problem is I have to control the clock for that. So Pat is also already mentioning it. I have to know externally, I need a microcontroller to load what I want to display, and I have to control the count of lines and whatnot. So that there is a lot of logic that has to happen outside, but let's assume, yeah, we have like an Hall effect sensor and magnet, or we use like a stepper to rotate quickly. So we know the actual rotations, so we can control it properly. So the clock, like the design for that, if you set the input pins to a certain state, and then you have like to put in the clock in the rate that you want to the next column to be displayed. So you control from outside the clock how to display the stuff. It needs to be like attached, like be synchronous with the rotation here, otherwise it would shift. And it's a little bit tricky as well because okay, design, let me check out. PDF datasheet. All right, here we go. That's the datasheet. Oh, okay. That's the amount of projects that are on there. There's some tests, PWM generator, UART, FFT butterfly, digital padlock, 4x4 RAM. Oh, that's mine. Option 23. Let's check. So people, that's a meme on my stream for whoever is visitor today. We had one. We had like earlier, like in the beginnings of the live streams, we were voting. We had I think a document or whatever, and we were voting on what project idea we will do on the live stream. So I put on, wait, let me, I put on several versions. Okay, here we go. First of all, it's like you can do a persistence of vision clock with a shift register. So this is basically yeah, option 22. That was like the first design. I had 3 days until the deadline to submit some designs, and I basically thought, okay, if you break down what this is doing, this is basically a shift register that you can load like with graphical data with, yeah, yeah, shift registers are basically FIFOs because you push out at the other end what you pushed in. So that's like a FIFO buffer, FIFO buffer with 8 parallel bits out, or 7 bits. Let's check what the data sheet says. 22 times. Okay, here we go. How it works. Right equals high. What is this data sheet? Data is shifted. Oh yeah, here. Right. So if input pin right is high, data is shifted on clock positive edge. Each 8 clocks, a full byte is buffered at the output. It rotates all 22 words. Reset only resets internal counter for the bit index. So what that means is, like, if you have like set reset high or low, who knows? It starts at bit 0, and then you have to serially shift in the bits. And if right is low, it will only display like the in 8-bit wise the output. That's very simple version of this thing. So the challenge here was like the maximum flip-flops that you can put in there, and it was 22 times 8, which is 176 flip-flops on there. And that is all that fit. I tried 23 and more and whatever. This is what we got there. Yeah. So yeah, you could also override. Interesting. I don't know what happens. The internal counter is like, I don't even know what happens if you write in at the same time. There was like, I vaguely remember, we can take a look at the Verilog code. I'm not sure. I wanted it like to not be interrupted. So if you clock in something, it still should display something. Yeah. Let me check. Yeah, the clock is variable. You can do whatever with the clock. So let's take a look in my ASIC. Oh, spoiler alert. It's option 20. I don't have option 22 I don't see it. There are like different versions. Okay, whatever. It's a little bit tricky because you have like serial input and a parallel output and then one clock. And if you want to override something, then what happens with the output, I don't know anymore. So we don't know if that works. Okay. Max clock. Yeah, we didn't know max clock back there. There is no requirements, let's say. Go as high as possible and as low as needed. What? Matt, design 137. Okay, there is another POV. 137. No. Wait, here. Oh, wait. You did option 23 serial? Okay. So Matt was testing. Okay, let me open this in browser. Here we go. This is what. Okay, so it seems it does something. At least Matt tested like option 23. So let's take a look at option 23 serial. It has a built-in character ROM and bitmap shifter for POV displays. So that's like better than the one before, and I show you why. Because we had like only with the graphical shift register, we had only 22, was it 22? Yeah, 22 columns here. So this is already, this is 1, 2, 3, 4, 8. That's already 16. And 22 is, so there's not much like that you can display with the shift register. The size like of the flip-flops was the limit, or the count of the flip-flops on that one. So I thought, okay, we want to display text. So I put on a character ROM with I think, was this one? Let me check. Yep. With your old familiar font from DOS or whatever, 8 CGA character ROM. Wait, let me check. Did I make a font converter? Oh, okay. This is how I work, okay? So I did let me check the code sources. I made this to generate. Okay. Now open it. Okay. That's basically it. It converts graphical data to a huge case. And that's just a piece of Verilog. Okay, so yeah, this is obviously on the PCB, which has a 7-segment display, so that doesn't translate correctly to the columns of the characters. But what you can do with that design is that's the data in, that's the write mode, reset, clock, and then you have like an over under. So if you have if you're displaying graphical contents, I think you can underline and overline them. So you can put some graphics in a frame, because the graphics are only six bits, are they? Yeah, it's a little bit complicated, but you can put in ASCII characters. So this is the formula. ASCII character number X plus 32 is like to put in data, and this is yeah, and this will be a bitmap, and the bitmap, oops, let me show it, and the bitmap mode only uses six rows. So bitmaps are always centered, should be centered, and there is like this over and under bitmap columns. So you can draw anything or an ASCII character. So what happens internally is it stores bytes only, or 7-bit thingies, which say, all right, if it's if the bit is like 1, then it's an ASCII character. If the bit 7 is, or 6 in that case, if you start counting from 0, is 0, then it's a bitmap. The issue with this design is that if there is a variation in columns that you have per revelation, because as soon as you use graphics, you have only one column per character. And if you use like ASCII, you have like 8, I think. It was 8, yes. That's it. So it will be challenging to do that. You have to be aware how many columns you're displaying per revelation. So you need to be aware or count your graphical data or ASCII data. Okay, so the question is, if I select a character, how many columns? Okay, that's a good question. I didn't. Let's find out. I have the design here. Top. Let's find out how many we squeezed in there. Word count 20. So we have either, if we use characters only, ASCII characters, because the character count is, so if you use ASCII characters, it's like 160 columns per revelation. So basic RPM divided by clock rate, right? Yes. So there is always some sort of external micro involved to shift in the data, and or like if it's like Wi-Fi or Bluetooth, because you want like on a blade, you want it to be not wired. I don't know how well slip rings work like with higher data rates. However, we have 20 words on that design. That means we can display a combination of word of characters and graphics. Imagine that if you want to like display a heart, you can do that. It would take four, how many is it? 5, 6, 7, 7 bytes for the heart, and then the rest could be text. So you have 13 bytes for your text and then the heart. But then this is also your column count. You have like 13 times 8 plus 7 is the column count. It's variable. That's unfortunate, but how else do you want to do this? I mean, you want to fill the ring and you have to spread all your data along that ring. I mean, we could do some clock division inside of that, but yeah, that was like not like well thought through at the end or whatever. So it's a little bit complicated, but I hope we can make it. I mean, it should be easy to use if you only use like ASCII characters. So like space will be basically 0 here and so on. So I think 32, yeah, is space and so on. And I have only, I think, capital characters. I think, yes, I don't know, not sure. And some, I don't have all the characters. I don't even know. Wait, let me check. Character ROM, how big that one is. Yeah, that's the character ROM. Wait, oh, this is a different layout for the character ROM. Did I do it like that? Oh wow, yeah. So quite a lot is optimized away, and I don't know how well that worked. Okay. Cells, what are cells? Oh yeah, that's a buffer cell. Wait, no, this is the like the predefined cells that we can use. Yeah. Okay. All right. So that's that project. Now let's see. Let's see. I'm talking. The introduction is already 45 minutes, but that should explain like a little bit of that design. There is another version of that, so I did a few versions, and that one is way easier to use. It has only characters, I think, or is it no bitmap? It has also bitmap and characters, but you have parallel in and out. Is there? Yeah, character ROM. So it's basically the same, but you only use 7 bits. Is this correct? Yes, 7 bits in and 7 bits out. And this is like 8-bit out. Wait, din. Okay, so if you set input to this bitmap column, if you set all to high, it will only do output. So I don't know, that might flicker if you want to shift in something new, and you might lose like track of the position or something. So that might be easier to control or to test because you have parallel stuff. Yeah, that's option 23. Well, what else do we have? 22 and secret file. Input clock, output 0. Leaving it alone works. Don't test me. External hardware shredder. What? What is nothing to see here? All right, okay. Yeah, here you can keep the type. Oh, embarrassing. This is how I blush. Hey Adam. All right. And yeah, let's make a PCB for that one. Cryptic loony. Yeah, I'm cryptic. Okay, how does it work? So, where is the GitHub repo? GitHub repository. No, this is, yeah. Nobody, this is like my design, my typos. Nobody has to approve. I don't know what, if Matt did some scanning for bad words. All right. So Pat did a repo here, MVP repo. Here we go. For this is the ASIC, and this is the minimal viable product or minimal viable PCB. Yeah, for the persistence, where is dark mode? How do you do dark mode in GitHub, on GitHub? Is there a dark mode? I like it. I like it bright and shiny. Extra light on my face, just for you. Apache license, nice. All right. In profile, yeah, not now. Okay. So it's still a little bit complicated. There's a lot of regulators. There is a flash for the Caravelle thingy, USB. So a ton of stuff, and I want only the stuff that's really needed. And thankfully, Pat did. Where is it? Where is the link? Full schematic PDF here. Here we go. Yeah, you can always you can always turn down the brightness of your screen. All right. Okay, here we go. Wait a minute. Is this is not the right one, is it? Didn't we have like optional? Oh wait, which one is optional? Okay. Dotted line. Here. Okay, here we have, let's do full screen. Optional and required. Okay, so of course, like this is required. Other PDF. Oh no, wait. Let me check what other doc. Wait, no, this is the wrong one. Tiny Tapeout. Here we go. This was Caravelle. Oh, here we go. I think, no, wait. Tiny Tapeout variant 1, 2, 3. Okay, that's it. All right. Here we go. Needed when using TT standalone. Needed when you... Oh shit, is this a different color? Oh, I'm colorblind. Foo. I need the color picker now. I can't see the difference. Oh, please, Pat, can you update the colors? Use like red, blue, and maybe yellow. This is this. If this is like green and orange, I won't be able to recognize it. Let me do a color picker. Okay, what do we have? All right, okay. This is okay. Let me zoom in. Maybe no, I can't zoom in anymore. This is this. Fail. Uh, yeah, I want standalone. Okay, so TTS required. Jordi is green. Okay, I want the green part, my favorite color. Wait a minute. Is this green? This is green. Standalone support. Okay. No, this is what I. Is this a different type of green? Ah! Okay, let's zoom out. Okay, scan chain driver and clocking. Standalone tiny. Okay, darker green. Okay, using a different like brightness might be good enough for those. Okay, this is also scan chain driver clocking. Standalone tiny taper requirements and knobs. Here we go. Project selection. Easy. We need RN1G. Resistance. C, E, F. What was this? Okay, let me. Oh, persistence of vision and a secret. Pull downs. Okay, yeah. So we need some pull downs. That's all. And these are pull ups. Is there like internal like default pull up? You mentioned something. If the only thing that I need that I want to check is if there is. Yes, nice. Okay. All right. So we can pull down or pull up. In that case, pull up is like just shorting to select our design will be easy, but we have to transfer that. That's just a selection for the design. We can do this with solder jumpers or whatever. Or what? Yeah. Or regular jumpers. I can do that as well. Yeah, we can do that. So easy. Only a few passives. 9 passives and some like jumper header that we can use. I don't think I have 8-pin dip switches. I might have, but let's use just basic components. Scan chain driver and clocking. The scan chain stuff is a little involved. Best to refer tiny tapeout documentation. Still notes. Okay, so what external logic analyzer internal. So we want external. Is this for the scan chain clock? The slow clock stuff you don't need to care about, as you will likely be playing with the clock yourself very manually. So tie the driver one to low. Yeah. Yeah, so that will be driver 0. Wait, oh, I have to analyze that shortly. Slow clock output, ground, slow. Let's check at slow clock. Or is it slow clock here? Slow clock driver. Both will be low. That slow clock is for clocking projects internally. Really, since when do we have both those low? Yeah. All right, that's that. And what else do we need? That's that. As when switching close, whenever value present pins use configure the clock divider need. Okay, whatever. We don't need that part. Now, okay, let's check. So clock, slow clock, voltage regulators. 1.8 volts is not typical on microcontroller boards. So I will just use a voltage divider with two values here. 3.3 volts we get from a microcontroller that will be controlling it. Bypass capacitors, all 100 nanofarads. Okay, yeah, just sprinkle them on there. Then we have standalone support, input out, so selection input. That's the driver. Okay, is that all? Flash memory, Caravel reset. Okay, you mentioned you changed something. SOC reset. That's the sheet we're just looking at. Okay. All right, that's cool. So we just need to pull it low, and you're using 1 microfarad cap reference to what is this? Pushboard reset manual. What is this? Do not pull. No, do not pull. But it needs to slow down to be well behaved. No, do not pull low. Just stick C25 and it's good on demo was. Okay, just to ground. That's okay. Ah, gotcha. Okay, so this is like enter and then just ground. Okay, so we need that oscillator. External clock needed to run CPU scan chain driver. Yes, that needs to be, what did you say, 20 megahertz clock. This is 10 megahertz. Yeah, I will be generating that with the microcontroller. We can just set up a PWM with 20 megahertz. Can we do 20 megahertz? Yes, we can. S3, yeah, I hope so. Maybe we should be able to put on oscillator there. But I think I will just generate it. No, I just don't know where my components are. That's the problem. I can't find anything here. I probably have 20 megahertz clock or 10 megahertz clocks everywhere, but I can find like maybe my passives and but all this like these active components I could order them, but it would be also nice to see like the secret file project. I will just attach it. I will make an extension board for my VGA board here. So this is the idea for today. Let's switch it. I will just plug it on that board, carrier board with the ASIC, and write a sketch that will basically control the ASIC underneath and provide the clock that's needed, or like we can tweak it even so. Oh, what? That took quite long. Oh man, you were the first one to buy them. That's like 2-3 weeks ago. But if you're using external scan driver, might not need any clock for the ASIC. Can you change? Okay, what? Change program for internal risk. And oh yeah, just you probably can. I mean, there's a flash for the RISC-V. I actually don't know how it works. Never. You just take a look at the Caravel. For external scan driver costs you what? 4 pins and some code complexity. How does the scan driver work? That's true, but it's a lot of work, and I want, yeah, you have, no, this is only for power, the USB. Scan driver, lots of pulses. Straight on the external flash. Okay. So let's take a look. Caravel. That's the flash. GPIO. JTAG SDO. Sock out. Sock reset. IO, cell, in, out. But where's the scan? Slow clock. This is the scan driver. Okay, I make you admin so you can post there. You can post links now. Pat. You know what? I mean, it's not that many pins. I can just use the pins that we have here. Oh, do I have 16? Ooh. Clock device. Okay. Yeah, that's too much text for me. Thanks. Thanks anyways. Okay, let's start KiCad. 1 hour is over. We have the intro and we will check out open, recent. We will make having 4 screens. KiCad doesn't handle multiple screens right. It just resizes the window crazily, or it gets lost or whatever. Here we go. It's like a randomly huge window now, and it's clipped. Thank you, KiCad, for nothing. Here we go. Okay, let's take a look at the PCB. I didn't look at the design for a long time. Okay, that's the PCB here, and we all right. So that's how many pins? Grid, not millimeters. We want 0. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 wide, and then we have the pins that the descriptions for the VGA board bitte was? Okay, start. It's what edits. Please. All right, so this is okay to use. Pull up, pull down, strapping pins, and that's my GPIOs. So this is TX, RX, which are output only. No, wait, input only. Is it output or in? Pull up floating SPI. That will be hard. We don't have. It would be nice to access all the designs. But I don't have 16 pins left. Okay. So for the secret file project, we do something very simple. Let's just start. Okay, let's start a new project. I just start new instance, KiCad 7. KiCad, stop! I lost the win. Where's the window? Here. It's terrible. Okay, new. Let me start a new project. ASIC. KiCad project. Let's do folder. I almost spoiled secret file here. So yeah, especially if you need 16 pins for VGA. All right, so let's start with the schematic. Here we go. Oh, we don't have. Do we have it designed yet? Is there a KiCad library for Caravelle? Yes. Oh. No. Let me. Is this in the repository? Oh, this is not a tiny tape out. You made symbols? That's cool. Yeah, otherwise I will just make one as well. Okay, I will download that. ASIC, ASIC, ASIC. Here we go. Caravelle. Git bash. Git bash here. Git pull. Where is the repo? Again. Sorry, you can see what I'm doing. I'm trying to check. Oh. Okay. Okay, here we go. Got it. KiCad lips. It's empty. KiCad schematic symbol lib table. Okay, here we go. KiCad. So we have that. Preferences. No, that's. I have to go to project. Couldn't you? Add import footprint assignments, preferences, symbol libraries, project specific libraries plus. Wait, no. Here we go. So you ask Matt that question. You just join the next Tiny Tapeout shuttle, and you will get 1, 2. I don't know. You can just purchase them. So I get a few because we have some extras from Tiny Tapeout too. Yeah. Okay. Why do I... What is this? I can't... Wait a minute. Let me open that. Let's see again. I just opened the project. This is the Caravel. And then we can export it here. Yeah, I'll just... That's in text anyway, so... where's my... Here. I have some pop-up here. Here we go. Here we go. Now let's peek a little. Oh, it's on. Really? Oh, I'm sorry. I turned it off. Sorry. Yeah, I use the symbol. I have the symbol cloned, and now we want a project. Oh yeah, I need to now use the document. Okay, so we have in and out. Okay, here is the in, and there is what? Oppa. It's awkward use. Okay, in in 0 is 59. Wait, I can close that. 59. Okay. Don't judge me. I'm always using that's okay. 59 is in 0 is 59 caveol. Yeah, okay, here. I will just oh. Oh. We don't need all those ins, but I can use it for the POV later as well. Persistence of vision. We can do both PCBs today. Okay. In 7, let's check. That's 5. Oop. Nope. In 7 is 5. Oh. Uh-oh. Didn't see that. Okay, here we go. That's correct now. Okay, that's the ins and dude, there is a TT naming Caravelle symbol in that lib. Oh. But what lib? I mean, I didn't change the symbol. Yeah, I don't have the lib because it's in there, not in my project. Wait, edit symbol. No, change symbol, not edit. Sorry. Here we go. That's and then Pat is giving me real-time support. No, there is no such thing. This is not the project. This is a different project. Oh, TT3. No, there is nothing there. So I didn't import the library. New library identifier? Oh man. Wait, let's start all over again. This is your workflow. So new library identifier. Yeah, but that's library not found in simple. Yeah. So this is I don't have the library, and I couldn't import a symbol library from the folder. It's only the project. So the only thing I could do is right now, there is no local library in the Caravel. Yeah, there is symbol library table. I don't know what. So here is the project. We have the project, schematic. No, that's not it. And in the library, there is nothing there. Okay. Let's do that. Oh, sorry. Ah, here we go. Man, you're so active. I didn't get it, but I will just download it. Footprint symbols. Here we go. Just place it there. Change Caravel. Here we go. Hey, Eric. Slowly but thoroughly. File import, add library project. I really need to be careful, otherwise I might spoil stuff for you. Tiny tape out. Is this the one? I will just add, oh, there are two libraries. Ah! All right. QFN TT3, this is the one that you wanted? Okay. No, TT3. Okay, here we go. Wow, annoying. KiCad. Stop it. Okay, so we have, let me think about it. Not connected, not connected. Flash, not connected, not connected, not connected, not connected. Clock, not connected. Ready out in thermal pad for whatever reason, because there is like only milliamps. In select and okay, so select will be high and low. I think there is a pull down for, should we, we have a limited count of inputs and a limited count of outputs. I mean inputs, outputs. I would like to maybe explore with this PCB. We only need like 8 bits in and 1 bit out from the MCU. So 9 bits. So we need all the, where is it? Outs. All the outs. Don't mind the direction. Oh, we might, oh, we can change it. Wait. No, this is stupid. Okay, this is the direction. Okay, F this. Wait. Copy paste. The pros are cringing. Watching me butchering KiCad here for stuff. All right, what is ready? Ready is like done with setting the output pins. Not really needed. We don't need that. We just wait. Whoops. Do we need ready? Hint, if you create label out and then hit insert, it will create, oh really? No. I can't select the other, I can't select the NC symbol. What? Okay, here we go. I don't need ready, we can just delay. Okay, let's see, let's check. Insert, oh wait, really? Okay, let's try it within. Oops, that's the wrong. Okay. Does it work with copied? Oh, what? It worked. What? Just pressing insert? What? Yeah, but it's the it's the wrong ins here. I just wow, okay. That's interesting. Where is the in here? In 3.0. Here we go. External scan. Wait. No, that won't work. No. No. I need to create it. And then it will work. Yeah. Okay. Something new learned. Okay. Select. That will be pads. Jumper. Let's see what we have. High, low. No, it's I can hardwire them, or okay, let's do it like that. Select. I will put it somewhere else. There's not enough space. Something like that. Cell 2, wait, cell 0. Cell 1. Bitluni died, did he? Or what happened? Did I die? I can't hear Bitluni. There is no TTS or okay, Pat, see you later. Have fun. Thanks for your help. Bitluni died. Yeah. Wait. Okay. Cell 2. Okay. 8. Wait, there is an issue here. I will check if that's still working. Okay. What will be the function of this ASIC? Okay, so the ASIC is already done. We have 3 different persistence of vision controllers, then 1 secret file, and hundreds of other designs from other people that is open source. So that's like a miracle ASIC, and we can select them with cell, the design that's currently going on, and we can input and output data from the ASIC. And there is some other stuff that we need just to set up correctly for our design like to be selected. I will do jumper solder jumpers for that. Wait, maybe like that. So I will just have an extension board for my VGA card, so I can process the file accordingly, maybe, and maybe test different designs as well. Okay, I will do the selection here. Or should I use jumpers instead? I mean, I can order as many PCBs as I want, so maybe I should yeah, let's do that first, and then we will do a complete design, another design on the other ones. Jumpers are easier. Yeah, I mean, this is like we will do another board only for controlling like the persistence of vision, and then we might get different design data in and out as well. There won't be a 7-segment display on. I won't use that, because like, I mean, there is already a 1 PCB that has that, so let me think. Yeah. Sorry. Oh, well. All right. What is the secret file design number? Now is the question, Does it start at 0 or at 1? Zero. Okay. One, 4, 5. That's 0, 0, 0. That's 32 plus 128. No, wait. 128 plus 16 plus 1. Yeah, that's correct. All right. So we have first bit flipped, fifth bit flipped, and last 8-bit flipped. Okay, this is high. Ah, come on. Okay. Yeah. And there will be ground. Huh? Did I press ground? What's going on? What? Look at that window. This is what KiCad does to me. What do you... Yeah. Hey, Christopher. Let me check if this... Ah, TTS is working. No. Okay, let's check again. High, low, 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 high, low, low, 7. Here we go. Okay. So this is selection. That's selecting secret file. Now I can hear you again. Thank you. Slow clock. Driver select. Slow clock select we had. Oh, really? Oh, okay, so we have some, there is an open. Oh, forget it. Oh, here we go. Okay. Okay, that will be 0. Slow clock. flash. Okay, what GPIO? What is missing? Okay, we need the voltage divider. Hmm. This is our, oh wait, let's keep it consistent. 1 will be 8. Ah, what did I do? Okay, what's 1.8? It's like half of that, a little bit. Let's find the resistor values. Yeah, that's half. 100. Yeah, should we? No, that's 100, 200. Yeah, it's just do value 100R. Not much, like microamps, milliamp, 1 milliamp. And that will be good enough, I guess. Something like that. 2 gigawatts. That's a waste of 3.3 volts divided by 200. Oh, what is this? 10 milliamps. Waste. We can do like 200. How we populate it, it's absolutely not crucial. Okay, where are the other designs? Did I close? No, there is the Caravel MVP. What? 1.21? What? VCCD, okay, is 1. CCD is all the CCD stuff 1.8? Yeah. Oop, sorry. Thermal pad. Let's just do NC the thermal pad. I don't know if this is ground or not. DDA. DDIO. VDDS. Always 3.3. We are almost there. Yeah. Yeah, it is. I don't know why. This is stupid road. Complain to road. I set it to 0 dB. It randomly changes. I hate it. If I had the cache for a new one, I would already got one. I don't know if I should go with DJI wireless mics or that's like another chore for me to like find that out. That's carve.io. SS is source, it's all GND, yeah. Now what? Have this. Whoop. Oh. Be careful, Matthias. We're almost there. All pads are assigned except for Caravel. I have no clue. Caravel RXTX, no need. We're not talking Caravel. Gigawatts. Reset B clock. reset was just a cap. Oh wait, yeah, we have to add some caps. What was the Caravelle reset, sock reset? Is this the sock reset? I think Caravelle IO is also not needed. Caravelle IO. Slow clock divider. Okay. Yeah, that's what I thought. That's what I thought. Okay, 1.8. So we need here 120. 1.8 is a little bit, well, yeah, that's it. And this will be ground. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times cap. That's okay. Okay, have fun, Sion. Oh, wait a minute. That's different ones. Okay, that's 6 of... Oop. Is it only 1, 2, 3? Actually, it's only 3. All right. Huh? Decoupling capacitors. Come on. Okay, here we go. What else is missing? Yeah, we have the slow clock stuff. Slow clock stuff. And then we need the connectors for other stuff. Okay, we would need, this is a slow clock, let's check. Bypass caps, that works. Clock. Headers, LED. Oh, GPIO is an LED. Interesting. Okay, pink LED time. So, was it carve IO? GPIO. Yes, 28. 28. Here. That's an LED. Hey, day for this, 520, 510, sorry. Yeah, let's take that. Or do we want a brighter one? We can do a bright one. We can do whatever we want. That's not the only board that I will do. I will do like an extra one with stuff with ESP32 and USB, which will basically access all the pins. You can then do whatever you want. I guess so. I mean, the S2 has many pins, doesn't it? What is 41 project? As the caravel, let's take a look at the, oh, where is it? I have too many windows open. KiCad, tiny tape out. Okay, this is the better one. 41 was the pin unused. Okay, that was easy. Careful. And then we have clock divider. Clock divider. Let's take a scan chain divider and clocking. Whatever value is present on in pins is used to configure divider. This signal is fed into in0 internally, so can be used to easily clock external. No, yeah, no. So can we ignore the other stuff? Enable clock, slow clock divider. One microfarad. Set diff. Slow clock. Ah. This configuration is difficult. We have 4 pins. Set divider. Yeah, slow clock driver. I will do the following. and we will get pin header. That was connector. Basic connector generic 1 times 4. That is messy, but what works, that works. Okay, that's one connector. Connector generic. Then we have VGA, we have 8. And 16. I think it was 16. Yeah. Okay. Now I think we have everything here. We will assign the VGA. Okay, so this will be VGA board. It's already there. Okay. Here is your pink LED here. Yeah. All right, so what do we have here? Is there VGA purple? Here we go. Hey, that looks way better. Let me just clone that stuff. Oh, there will be pink. Okay, enable ground IO. So okay, now we will attach the pins. So these are bootstrapping pins. So now I need 1 clock, 8 outputs. Let me check. S3 data. What? Edge, Please stop harassing me. Room. Room PDF. Uh-oh, is there a second room? Is this compatible with... Okay. Let's check GPIOs. Do we have any limitations on... Every GPIO is IoT, IoT. Six. I don't want to connect pins that are not usable. Okay, there is no limitations on this ESP. So let's do it. This will be output. Wait. Um, 5, 6, 7, 8, 9, yeah. That's basically it. Bloop. Bloop. And then we have unfortunately not so many. Let me check what design. Serial. Over, under. Okay, I need like the first 6. 6 for that one. That's full. That's 4. 4 and 6. Hey system, how are you doing? And in. Okay. So what we want is this will be in Yeah, 4, this is here, 6, 7. Okay, and we will get maybe we should use jumpers instead. Okay, let's use jumpers instead of. Okay, ground. Okay, so let's no worries. Connector pin. Connect. Wait, yeah. I can't even remember when was the last time. Probably in my old lab still. Where is this? Oh yeah, pin socket, here we go. 3 pins. Ah! Difficult question. It's so much work. Unbelievably a lot of work it is for me now. How's Luni Lotte? So, I don't know if you know Laura Kampf, but basically I'm doing like a drainage right now, and it's really hard. The weather is bad. What? Okay, good night, Jordi. I should finish that board ASAP. Three is one too many, huh? What did I do? Am I sleeping already? Probably. Yeah. Oh, yeah. So, then you saw how much of work in the basement I got here, and the basement is it's dry now currently, and I dug up like one side of the house and currently insulating. Today I wanted to put like the first layer of bitumen on, but then it started to rain too early, so I had only the primer, and I hope I have like a time frame of 2 hours tomorrow morning at 7 o'clock to put on bitumen and then a few hours later to put on the second layer. And I hope like this weekend I will be able to put in the drainage pipe and the gravel, and there's like a sequence of should I share a little bit? Yeah, I think I have some stuff here. Okay, now we can select everything with jumpers. Okay, select with jumpers. This needs to be a certain value, 1 microfarad. Okay, so it's a little bit Caravelle IO. Okay, I think we have all. Now we... Oh, okay. Just say when you're there, so I will show a little bit. And I will do parts assignment. So this is stored. Loop. Oh, nice. There is a QFN. That will be... yeah. And those as well. Wait, I'm missing the clock. Okay, we need to like, we will have, I won't be able to use underline, overline. Yeah, that's not important anyways. Okay, connect. Pin header. Oh wait. Oh no. Vertical. Here we go. Jumper bridge. No. Jumper 3. Jumper 2 open. Jumper 3 bridged. Jumper. Jumper to rounded to bridged pad. Here we go. Now LED LED. Wait, bitluni basics. LED 0603. Here we go. Assigned. Now I have the, where's the clock? CLK there. That's missing. Sorry, not sorry, but this will be the clock. All right, clock. Or do I flip it? 0 for clock sounds nice. Nah. Let's do it like that. Let's leave it like that. And that's it. I think we can do the PCB design. This will be an easy one. Secret file. We need to make it look like a disk. We make it look like a disk. Should we? Yes, we should. Make it look like a disk. Oh, I have an idea. Oh. Yes, I have an idea. Yes. So, this is jumper. Nah, it's all right. Like a compact disc. Not a compact disc, sorry, a diskette. Okay, so Grid size should be 2.4 millimeters. And then oh, really? Am I so silent? Stupid laugh. Okay. Now I need VGA project. One, two, three, four, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Hope that's correct. This will be a challenge. This unpopulated thing as well. Wait, there's no, the VGA connector is up there. There is an antenna here. That's a lot of jumpers here. Orientation 45, huh? Old trick. Would be something like that. I regret I put on the jumpers now. Phew. This will be a routing nightmare. No, I can't do this with these stupid jumpers here. Oh no, I deleted the other solution. Phew. Okay. Ah. Let's restore it. Sorry. This is just too much. Too much of a hassle. Ah. 3, noch eins. H. I don't care if it looks shitty. It's a puzzle anyways. I hope I got the selection right. That should be 128 plus 16 for 145. Yeah, that should be alright. Oopsies. Assign it. Refresh it. And now let's put it on the back maybe. All right. I think we can put them all on the back side. Maybe something like that. Grid. Yeah, that fits. If it fits, I sit, is the rule. Hoopala. We can still move it down a little bit. There is a smaller gap than here. Can I root something in between? Yes, I can, okay. Oh, well. The board is the size here, like few centimeters. I don't know why this one. When I move this center, this is a different center. I don't know what this issue is here. Don't show me that. No, I won't mill that. There's no way in heaven. Wait, no way. No way. There's nothing to do with heaven. No way anyone will force me. Ah, now it's the right distance. Okay. All right. This is optional. Right. Yeah, we can put it closer here. So what else do we got here? This stuff. I need another grid. Okay, that's all right. that might need to move anyways. Like that. We need some space for this stuff. That's some huge pads. Stupid stuff. Back sides. Pads should be on the back side. Okay. Now we need some decoupling and stuff. Okay. What is this? This is the LED. LED needs to go here. Oh, somehow I don't get, new people don't get voices as signed. So I couldn't hear you, Ingrid. Yeah. Yeah, it's like, it's one ASIC where people put their open source design in, and you can select the active design. Where's my paint? I have MS Paint open somewhere with the explanation. Here, there's like a RISC-V that controls. Yeah, and you can activate like the design that you want to use, and there are inputs and outputs. And I made like a persistence of vision design that has a font, like a font ROM and so on, and a secret file. And this is another one that tries to access the secret file. And I'm doing a minimal design for, okay, let's disable all the text. Reference designator. Okay, now they're disabled. Yeah, with my typo. Here we go. My headset is signing off, but I have a second one. Booster. All right. What is C1? Oh yeah, that's all caps. That's the reset cap, isn't it? Reset, yes. That's the reset cap. Let's put it here. That's the voltage divider. Whoopala. Ah. Yeah, here we go. The voltage divider. Then we have some caps. 3, yeah, that's the 3. Which are all optional, in my opinion. Ah. Yeah, but it's like not my... I just participated in this insane project, so only like with meme stuff. The actual people behind this are so intelligent and knowledgeable. I can only have respect whoever, yeah, took their time to like figure all this stuff out. This is amazing. So now there is like an open source tool chain, complete tool chain, including how the silicon has to be manufactured, or the gates or whatever. All that is open source, which is so cool. Okay, these are the caps. It's looking strange, but this is where they are placed. Oh no. Shoot. Wait. This is shitty. This looks shitty. And where's the other 1.8? 1 point. Wait, did I destroy my divider? No. Huh? Oh no. What did I do? Where's my resistor? Yeah, I destroyed my voltage divider. Here, this is my voltage dividers. Don't touch it. That doesn't need to be there. Hey, Max. Oh, you know what? Is there a way to rotate just by 45? Yeah, that's the origin of my name. Lunatic. Eh, eh. Wait. Eh? There's the 1.8. Here, next to it. What? Okay, bye-bye, Casper. Oops. What is this? Where is this coming from? here. Okay, whatever. Right, voltage divider. Moves here. Now, wiring, components are placed, and I hope wiring works out, otherwise I'll just make a 4-layer board. Alright, let's take... wait. Zones, footprints, all items, dimensions, other items, graphics. No, there is no auto routing in KiCad. Is there? I don't know. Uh-oh, this is outside, this is outside, this is outside. I also want really this to be move it here. Wait, what is this radius? Yeah, I guess I could use it. I mean, it's not like... How do I align this? What's the grid step here? You know what? Okay, here we go. That's it. Let's wire it up by 3.3 volts. No, wait. Let's do ground first. How do... Okay, I do some crappy job here by routing stuff. know what? I do both. Here we go. What? Wait. Ground. Okay. Here we go. Solved half of the problems. This should move up again. Hey Bleep, how are you doing? Oh no. It's the wrong. Oh. Okay. Here we go. Let's root some stuff here. This huge pad. Oh, really? Cool. Congrats on that. I'm envious of you that you do such a cool stuff. And I have to stay at home and fix my stuff here. Wait, this is... Yeah. Blip, blip. Yeah. Oh wait, this is not rotated. The cool stuff, the weather, like I try to fix the house. Today, oh by the way, Johnny, today I installed Shelly in my junction box. So that's something for Home Assistant. Not? I loved it when I was able to access it. Maybe it's cheaper now again. They made it so stupid for... Yeah, I'm not convinced of the quality yet, but it's like it doesn't has like the feel, the tactical feel of a good quality plastic and so on. So, and the like the screws to like tighten the wire, the holes are so thin that I have like to take a screwdriver that's not like protected for has no like hull on the shaft for protection or whatever, because a regular screwdriver wouldn't fit. Stuff like that. It's a little bit annoying, but oh well. Okay. Bam. It's, the holes, the screws are okay, but the holes are even like... VDE. What are the regulations there? Please tell me. I mean, let's say it seems that we have two different naming conventions here. I have to update the junction box and the wiring in the house and so on. Every time I touch something, my to-do list just gets longer and longer. The best are the cage terminals. Oh, did I change the wrong? No. Oh, wait. I have to update like that. Boop. Close. Okay, here we go. Oh, wait. We have also the front. But yeah, I'm getting there with the home automation. I need to. So today is the first day we have heating going on in the house, and we had already freezing temperatures. So yesterday I fixed the hot water because we have a solar water heating system, but it was too cold for the water to get like above 30 degrees, which is not like comfortable to use, and sometimes even less than that. So, and it's such a complicated system because we have like 2 meters. 1 meter is was switching between like 2 rates, one night rate and a day rate for electricity, because we have like this Nachtspeicheröfen, which is basically heating up in the night when power is cheap and dispensing the power through the day. But this is not how it works anymore, because there is no extra rate for the night. But there is like still a box inside my breaker box that basically would turn off like a relay the power for the complete heating system. But the relay burned at some point because it was so old, it fell apart. I let an electrician replace the relay, but it will still not switch on the heating system because like this stupid control box that's not my property, it's the property of the provider, and that doesn't work anymore. So I bought another like electrical switch that accepts like the signal, but also has a manual switch that you can just turn on. So I installed that myself because I didn't want to let the electrician come a second time. It was quite easy to switch that. And then everything starts like it's like a chain reaction. Now the heating system would be like heating all day long, and I don't want to do that. So I have turned off all the breakers for the heating system. I just wanted to turn on like during certain times or whatever. So I installed a Shelly, and now I have to wire the Shelly to turn on the switch for the heating, also for the heating of the water, which I will install another switch. So I have a different Shelly channel for heating the water, because I want to make it dependent from the weather. Since we get the water heated by sun, it's not necessary. If there is like a sunny day, I really need like to wait to heat the water with electricity until the evening, so we can harvest as much like hot water from the sun as possible, and then top it off with electricity. So this has to be like automated. Then it's a huge mess, and everything is like not up to date because there's like this, I don't know how it's called, like FI switch, like that's new standards. That's only done for the bathroom here because the bathroom is from 2012 and everything else is older. Like the electrical installation is from 83 maybe. Dry contact, yeah. Dry contact? What is dry contact? Especially since I'm not always here. I will go like next week to California, and Tony will be here alone. She won't be touching the breaker box and switching on breakers off and on to like heat the water or whatever, which is stupid. Ah, yeah, all right, yeah. Yeah, that's basically it. I have like this, I don't know, in German it's like called Schütz, so it's like an electromagnetical contact, and it has an, on top of that, it has a like switch. Also like the Shelly, they support like a dry like switch as well. Dry also called. Yeah, yeah. I bought like, it cost me over 100 euros. Um, what's the name of the device? Do I have the box here still? Should 63 amperes, noiseless. Which one is it? Switch. Brummfrei, I think. Let me, oh, where? Oh, where is it? I can't find it. Here. Lengard. Where is it? It's the Lengard. Legrand. Here. I bought that one. No, but this is not the noise free. So because the breaker box is next to our sleeping room, the other one is even more expensive and it's hard to get. Wolf. Here. This is the one that I got. Yeah. So it can switch like 63 amps, noise free. Four contactors, so you have neutral. You could switch neutral probably as well. I don't know. It has like, it's a four-way switch or four contact switch. with manual, you can open that and basically turn it on, or use like this, the phase here, phase switching. Yeah. Yeah, and they're like, the contacts are really chunky. Like you can put some current on that one. And that's needed for the heating system, actually. I got that one, and I got another one for 40 amps, which I can use, I mean, that we couldn't use at the end. Yeah. Oh, wait, I wanted to use another track. So, yeah, it's a never-ending story with auxiliary. What do you mean with auxiliary? I mean, I can switch it on with, yeah, here, A1. This is like the, you give it like, I connect this to the Shelly, and the Shelly will basically turn that on and off. So I can turn on off the complete heating system. Yeah. So, yeah, this is like a magnetic switch. And this is just a manual override. You can just, this switch is even only rated for like 100 users or something, or 1000 users, while like the magnetic is obviously for 10,000 or whatever. So this is like just a manual override, and I'm currently using it in the on state, because the signal from the control box, from the energy net provider is not like working. Like this old rusty box is basically broken, and I don't get this signal, and I don't have a 2-rate contract. I have only a one rate, so the signal is obsolete anyways. Yeah. I will use them, like one of those, but not that one, for the water heater, and try to automate like with sunshine, with weather forecast, which will be cool to save some power. All right, 0.5 millimeters and whatever. Oh no! What? Didn't it store it? I need to press OK. 0.5. OK. Where I live, I had to install a self-rearming residual current cycle. What is that? Self-rearming residual current circuit breaker. What? Ah, why? Oh. Interesting. So you prevent like people, if the power is gone, and then you stick in like a fork into the outlet, so you won't get shocked when the power comes back on. Guess super safe is gooder. So with the GFCI. Yeah, I think this is mandatory in Germany as well now. Here, Fehlerstromschutzschalter. That's FI. RIA. How much does that one cost? 44. Yeah, that's manageable. How much? Yeah, 63 amps. Where is it? All right. Yeah, I have to update all that stuff, but then my breaker box will explode. It's full already. Ream feature costs double. Yeah. Okay, let's finish that up because I need to. Okay, this is necessary. Half a millimeter. Is this half a millimeter? Doesn't look like half a millimeter. Here we go. Let's do more. Wait, this is not half a millimeter. Didn't I select half a millimeter? What? Good night, Dave. Okay, so this is because we dissipate a little bit of current here. This is also 3.3 volts. Clock, okay, use track. Do I really want to wire the clock like that? Oh, come on, this was... Ah! Eh! Ah! Okay, that one needs to go. Bloop, bloop, bloop. Bloop. Oh. Wait, X, here we go. Boop. Boop. Wait a minute. Oh no, this will be a routing nightmare. Especially with that. ground. Ground is gone here. Komm schon. Uh-oh. How do I get there? You know what? I don't. Ah! Then it's some more TV for you. Okay, I need some space here. So let's move that, since we have now more real estate here, out of the way. And this can move over here. Drag this over here. Here, drag this there. Do I even need that anymore? I don't need this. This will be enough. Yes. Just touching that. Okay. By the way, thermal relief gap, minimum width, clearance 2.5. Here we go. No, that will never work. Look at that. Oy, oy, oy. We have so many pads to handle here. Oops. Uh-oh, too tight. There you go. Okay, let's move it around a little bit. Drag it over here. That can go away. We have plenty of space over there. It has a thermal pad, but I believe it's not necessary really. I could use like a different design for this. It doesn't draw any current really, so. You know what? Wait, is this paste? Yeah. I think this is paste, okay. Yeah. No, I don't mill it, so I don't need to stick because I have then solder. Whoop. Ha! I have not solder. There, I will have silk screen. That's good enough. Here we go. Hoppala. Bye, tech. Wait, that one can stay there. I will do just that one here. And that one. I don't care. If it breaks, it breaks. You know me. Wait, that's a limited chip. There won't be many. Okay. I should hardwire this selection. Why is this broken? I think this is to... yeah, that violated the clearance. I think, yeah. Something like that. You know what? F this. I do the via here and wire it there. Is there? Oh, there is even one more. I hope that... no, it doesn't fit. So I have to drag it over here. There's no way. I don't want to move the chip again. But you know what I can move? I can drag this thing. Wait. Ooh. No. Ah. Painful. Yeah. I tell you, if it doesn't work, it doesn't work. I just want to get it before... Huh? Where's this going? Oh yeah, that's the ground pad. Wait a minute. Are we done already? Looks like it, huh? All right, let's get some voltage going on here. voltage, 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 voltage. Empty, yeah. I hope we won't be doing that. I mean, I have some mystery with these pads here, so that's why I added like pin header connector, whatever. What's missing? This is missing. Okay, let's wire this. There's no way we can wire this. Front layer maybe. It's not so important. Oh no, really? Okay, let's do it. Okay. Oh no, we have all the outs. Oh! Ins and outs. Shoot. I didn't want to do a 4-layer board, but I might want to. I might need no 4-layer boards. I want an express delivery. Oh, that's a lot of stuff here. All the selectors. Foo. This is already too convoluted. Desperate times require desperate measures. No. I don't care about any other projects. I will add nothing to nothing. I will just select my secret file project, and this will be only for that, nothing else. That's it. 117, 128, yeah, 45. 145, that's the one, yes, it is, is it? 145. Secret file, okay, here we go. Whoop! Yup, bop, yip, boop, yip, yip, bip, yip, yip, bip, yip, yip, bip, yip, yip, bip, yip, yip, bip. Look at that. Go away everything. Boop. And this looks like it needs to go here somewhere again, where it was before. I just put it there, leave it there, and that's it. So I have enough space for the other trash. Okay. Let's do the furthest. Furthest pins first. Power last. Power doesn't have integrity. Hey. Eh? This is what I want. Oops. This is unnecessary here. Okay, what? I'm done with those, okay. Use. Oh no. Come on. Drag it. Yeah. Okay. Okay, power lines, my friends, power lines. 3.3 volts. Let's get it rolling here. let's get it over here. Then we do a via here and here. Here we go, and let's select U 0.5 chonker, U 0.5. Yeah, we have both supplies here. Okay. And via bam. Via bam. Wait, this 1.8. This one is a little bit encapsulated here, but if we drag it out a little bit, like that, that might work. Yep. And what do we have here? That will work. I don't have any space for anything here. You switch to front layer. Okay, we need some ground stuff. This is easy. Nah, it doesn't do anything. I have an idea. Okay, here, drag this over here. X via and oh no. Yeah, all right. Screw it. Ground. Yeah, that. I will connect this basically here. The only one missing is 1.8 volts. Okay. I think that one is not well reachable. This one either. Can't go over there. I can go down. I can go over here. Can I go here? No. Oh, this is painful to do, but I'm out of ideas here. It's the same here. Can't reach that. That's just on both layers. Okay, here we go. Okay, we have 1.8 connected here, connected here. That's all. That's all what we needed. So we just need to connect some grounds. So I will just put on some ground vias here. This ground is disconnected. Will that work? Boop. There we go. It looks trashy. So let's do it like that. That's the sketch select. Oh, 3.3 is the, here we go. That's cool. This one. Some ground pads here. Can't fit it there. Maybe if I drag it a little bit. 46, yeah, you're right. Dear M rules boop boop. Here is one missing. There is one. What's with this area here? Maybe this area. Bloop. All right, that's DRC, not DRM. Oh! Errors. Okay, unconnected items. What? Where? Oh yeah. Clearance. What? What clearance violation? What? Okay. There is a here is one. What is here? What's going on here? This ground is not connected. All right. Let's drag it a little bit. It's pouring outside. Oof. I hope my trench doesn't drown. Oh wow. Which one is missing a connection? What is this? Oh yeah. Yeah. Uh-oh. What is this? Where did that come from? Oh no, I moved that footprint on top of that clock. Oh shit, my trench will drown. I can hear it pouring really hard outside. Ah. Oh, that might work. Courtyard, courtyard, courtyard. Silk screen footprint. Okay, what do we have here? Pet zone. I can't see it. Here, ground. Is this? Yeah, this is isolated. Here we go. That needs to go over here. That needs to go over here, and we need. All right. Oops. Okay, one missing connection. What else? This ground pad. This ground. Oi, this one is hard. Wait. No, it isn't. This one. Huh? No. Okay. So the issue is, yeah, that this ground doesn't reach anything. No, there's nothing there. Oh wait, the front layer, okay. Yes. one more. This ground. Oh, well. Okay, error, courtyard, 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 silk screen, courtyard. Okay, what, yeah, this is all right. This is not, yeah, this is all right. Come on, that's not that bad. That's also all right. Oh, no, no, I'm not out of TTS on purpose. My phone died. Thanks for notifying me. But there was not much text. Ouch. Oh, my hands are dying from... okay, I think I'm done here. I just need some art. So let's do some silk screen and draw a diskette like that. Okay. So we have the lines here. Wait. Floppy disk. Good night, Max. I can't edit this. This is stupid. Okay. No. Okay, here. Wait. This needs to be really far over here. And why is this? I can't understand. All right. All right. We're almost there. This is our art. Come on. I cannot move this. Here we go. Can I do an arc here? Yeah. So let's try an arc here. I hope that it's close enough. Yeah. Okay, here we go. All right. Text. KiCad font. Yeah, whatever. This is not. Ah, are you kidding me? Oh wait, text. Back silk screen. Here we go. Okay. Here. That's it. Okay. Yeah, no. Orientation. Still a little bit uncentered towards the B. Okay. So this is how it plugs in. Maybe we do the orientation like that. Okay. DRC. Courtyard sphere. Yeah. Courtyard 6 screen footprints. Okay, close. Let's send it to Isla. Deploy. Oh. Hello? I'm not logged in or what? Why are you not working? Alright, let's close it. What changes? Caravelle. Secret file. Let's reopen it. Sometimes that doesn't work. Ah, now it pushes. Okay, here we go. That's what it is. Yeah. I will check it out, and that will be it. Don't spoil any. Uh-oh. J1 pin 3, J1 pin 4. There's some detected. Wait, close it. So Isla detected something. Let me check that out. Oh yeah, here. Oh yeah, that's all right. That should be it. That's connected to ground. Okay. Everything all right, Mr. Isla? Oh. All right. Look at that new layout. Let's do the blitz service.